So the next topic of this video is vector or cross product. So first of all, there is a definition of vector or cross product. The vector product of two vectors a and b is a vector which is defined as a cross b, which is equal to ab sine theta into unit vector n, where n is a unit vector perpendicular to the plane containing a and b as shown in the figure. Its direction can be determined by right hand rule. Suppose these are two vectors, vector a with blue color and vector b with green color, with both are inclined at an angle or inclination theta, and angle is taken as counterclockwise, and the cross product of these two vectors is perpendicular to the both these vectors a cross b. This is cross product, and its direction is determined by using this unit vector which is parallel to this cross product or vector product. The direction of the product is perpendicular to this plane and it is determined by right hand rule. Suppose this figure shows the right hand rule to determine the direction of this vector, in which this thumb represents the direction of this cross product a cross b, and when you will keep the thumb erect and curling fingers perpendicular to this erect thumb, this will show the direction of this cross product. Because of this direction rule, a cross b is a vector perpendicular to the b cross a. This is b cross a, in which the vector or cross product of a cross b is totally reverse of a cross b, and b cross a is the shown with negative sign because it is 180 degree in opposite direction to a cross b product. Next one is the characteristics of this cross product. Since a and b is not same as b cross a, the cross product is non-commutative. Since both these have the opposite signs, so this is not commutative. Second one is that the cross product of two perpendicular vectors has maximum magnitude a cross b equal to ab sine 90 degree, because angle is 90 degree in this case, so sine 91, and a cross b is equal to ab into n into unit vector. In case of unit vectors, they are mutually perpendicular, so I cross j is equal to k, j cross k is equal to I, k cross I is equal to j. Third one is that the cross product of two parallel vector is a null vector, because when theta is equal to 0 or 180 degree, so sine 0 is equal to 0 and sine 180 is equal to 0. Therefore a cross b is equal to 0. As a consequence, a cross a is equal to 0, because both the vectors are in parallel direction or anti-parallel, but in both cases a cross a or self product is 0. Next one is that cross product of two vectors in terms of their rectangular components is given in this form. The result can be obtained for a memory in a determinant form, since these two vectors can be represented in the form of matrix I, j and k, ax, ay, az, bx, by, bz. The magnitude of a cross b is equal to the area of the parallelogram formed with a and b as example of vector product. The vector product of our calculation due to this torque. So first one is the torque and second one is the force on a particle of charge q and velocity v in a magnetic field of strength b is given as F is equal to q into v cross b, where v is the velocity of magnetic field in a magnetic field, b is the magnetic field strength, q is the charge.